Okay, let's evaluate the integral of 6x cubed times the square root of x squared minus 2. Of course, it's an indefinite integral because we have no numbers over here and there, right? So, let's get started. I will use the substitution rule, and I'll say that x squared minus 2 is just u. So u is equal to x squared minus 2. So let's find the differential of u. So right below, we'll just write du equals. Now I will need to take the derivative of x squared minus 2 with respect to x. And the derivative of x squared is just 2x. I'm sure you all know this at this point. And the derivative of negative 2 is just 0, so I don't need to write anything down. But once we are done finding the derivative, I just need to write dx here at the end. Great. Now, what do we do? Well, what I like to do is just multiply both sides here by 1 over whatever is multiplying the dx, which is 2x. That way they cancel out. So I have the dx, I can just actually replace it right there. So we have 6x cubed times the square root of u times dx, and dx is just 1 over 2x du. Great. Now, x cubed over x is just x squared. So that's a 2 now. Not to be confused with, well, that's the square root anyways, but that's just x squared. 6 divided by 2 is just 3. And I can actually take the 3 outside. So I will just rewrite it because it's getting pretty messy. So we have 3 times the integral, and we have 3x squared times the square root of u du. Of course, we don't want to see an x here anymore, let alone an x squared. So let's actually just rewrite the x squared in terms of u. We know that u is equal to x squared minus 2. So I can just add 2 to both sides of the equation, and I get u plus 2 is equal to x squared. So I can take that and replace it right there. Okay, so we have, oh, and I mistakenly wrote this 3 again. The 3 is gone. Whoops. Because it came outside. So we have 3. Hope I didn't confuse anyone with that. And now he must be saying, yes, you confused me. Sorry. Hopefully it makes sense now. So we have u plus 2 times the square root of u. Okay. Now what do? We have 3 times the integral, and we have u plus u times the square root of u. What we need to do is actually distribute the square root of u. Wow, how are we going to do that? Well, square root of u is just u to the power of half, right? We must, of course, remember our exponent rules. The u is just u to the power of 1. So u to the 1 times u to the half, we can add the exponents. 1 plus half is just 3 over 2. Whoops. So 1 plus half is just 1.5 or 3 over 2. And 2 times, now note that we're distributing the square root of u. 2 times the square root of u is just 2 root u, or 2u to the half. I'll just keep things consistent by writing the exponent in fraction form. And I still have the du right there. Now I can finally actually take the integral. And what is the integral of u to the power of 3 over 2? I can just add a 1 to the exponent. If I add a 1 to 3 over 2, I get 5 over 2. And I'm dividing this by 5 over 2. Or in other words, I'm multiplying by 2 over 5. Right? Because if I divide by a fraction, I'm multiplying by the reciprocal. And the reciprocal of 5 over 2 is just 2 over 5. Over here, we have the 2 times u to the half. What's the integral of that? I need to add a 1. So 1 half plus 1 is 3 over 2. And I'm dividing it by 3 over 2 as well. So in other words, I'm multiplying it by 2 over 3. And I'm adding a c at the end. Because this is, of course, an indefinite integral, and that's what we always do. Please do not forget to add a c at the end. So now we have 3 times 2 u to the power 5 over 2, but I'm going to replace the u for x squared minus 2. So I have x squared minus 2 to the power of 5 over 2 over 5 plus 2 times 2 is 4 times u to the 3 over 2. U is just x squared minus 2 all over 3 times, plus c. Not times, plus c. And then the last step, of course, would be just to distribute the 3. Then we would end up with 6 over 5 times x squared minus 2 to the power of 5 over 2. I'm losing my breath with this question. 3 times 4 over 3 is just 4 times x squared minus 2 to the power of 3 over 2 plus c, and we're done. So that is the integral of what we had originally, and that's it. For more questions, check out our website, and good luck.